Thank you, Niklas. Hi everyone, my name is Davide Zennaro. I'm a consulting engineer at Cisco Systems, Cisco CX. And in this session, I will share the experience of Cisco CX team of delivery on the testing automation for a generic NSO service provisioning package. So this is an approach that we have been using for quite some time now. And it says general because it is used to test packages, NSO service provisioning packages, irrespectively of the specific configuration that is pushed to the devices. The approach, which is used in the internal testing for the delivery of packages, it is coupled with a process. And we think that the approach together with the process is basically very effective. And it allows us to scale in 2 dimensions. So one dimension, we scale on the number of packages, because again, we are able to test in an automatic way, multiple packages, but also on the number of test cases, as we will see. So this is the agenda of the meeting. So first we will see the scenario. And secondly, we will see the reasons that brought us to look for a general approach. And then we will see a little bit of a high-level view of the approach. Then we will try to understand what are the added values in our opinion. And finally, we will try to draw some conclusions. So basically, one of our priorities, of course, when delivering software is software quality, right? So how to achieve that? One way is to test. And in order to do that, we wanted to automate the testing of the NSO service provisioning packages. Which kind of tests we are focused on? They are functional and regression testing mostly. So functional because we wanted to verify that the packages that we develop actually satisfy the requirements. And also the package that any feature that is developed actually does not break something that was working before. The tools that we use is a robot framework, it's a well-known framework for testing automation. And on top of that, we use some keywords of the Cisco CXTA library. So the Cisco CXTA library is a library of keywords, which is part of a Cisco CX service offering for testing automation. And in the specific, we use Cisco CXTA keywords mostly for interacting with NSO, and also, for example, for comparing device configuration. So we also use the testing automation tool in our internal CI/CD pipeline. And that is mostly also used for running automated tests, also for regression purposes. So what are the reasons that brought us to look for a general approach? So as I said at the beginning, one of our main points was we wanted to scale. We wanted to scale both on the number of packages, and we also wanted to scale on a number of test cases. And that is in order to have a very good coverage of the packages that we are testing. So basically, one of our driver was doing the extensive testing. And we are aware that different packages behave in different way, meaning they configure device in different way. They configure they apply different configuration to the device, right? So what we tried to do was to focus on the similarities instead. So we test different packages, but we try to find a way to test them similarly. And that actually brought us to a common approach, which translates to basically a common robot code base that we use to test different packages and to run different test cases for each test suite. I think the main takeaway of this slide is that we try to focus on the similarities, being aware that packages are different, but what we try to do was to focus on the on a common way to test the packages. So basically, what are the high-level phases that we go through as part of this common robot code base? So in this case, for describing how this works, let's assume that we validate the package against the configuration on the devices. So we have an alternative, as we will see in the next slide, which is validating against the NSO configuration database. But for describing this, let's just focus on the device configuration validation. So what we do is, in the first phase, we get a picture of the network. So we get a network status. We collect the configuration of the devices which are interested. Phase 2, we execute what is the object of the test. It might be, for example, the creation of a service instance. Then we take again another picture of the network. And in phase 4, what we do is to take the output of phase 1 and phase 3, we process the output and we validate against an expected output. So, the test structure that we use is composed by we call them 2 steps, up to 2 steps, and multiple prerequisites. So why we consider the possibility to have 2 steps? That is to test possibly the creation of a service instance and the subsequent delete of the same service instance. And we allow for prerequisites because sometimes when we develop packages, it might happen that in order to create a service instance, some prerequisites need to be on the devices or on NSO, like for example, policies. And also we allow the test to be rolled back. There are cases in which we want the test case to be rolled back to start fresh with the next test cases, or there could be also reasons for not rolling back. Again, also the validation is a choice, and there might be cases which we want to validate, and there might be cases in which we do not want to validate. The validation, as was mentioning, we have basically 2 options. One is validating on the device configuration, and the other option is validating on the NSO CDB configuration. And finally, we allow a test to be positive in the sense that we expect success, or a negative in the sense that we expect failure. So, in order to scale with this test definition, let's say, on the number of NSO packages and on a number of test cases, what we did was to use basically a test list per test suite with test parameters. And of course, in order to perform a test, we need something, right? We need the payload to be sent to NSO. We need the URI to point to send this payload to NSO. And also what we need also the data that is necessary to validate, which is the expected output. We put all of this information in the test list with the test parameters, and we make use also of templates for input and expected output. So this is especially, let's say, useful in the case of input because whenever we test a package, we are basically leveraging the same Young model, right? So what was useful was to derive a few number, let's say, of input templates and specifying variables inside the templates and specifying the values of the variables inside the test list. And that is also true for the expected output. So of course, in order to use the input and the output, the expected output for a test case execution, we needed rendering phases for these templates. And all the variables that are mentioned inside the templates are actually, I mean, they find a value inside the test list for each test case. So this is a summary slide on the process that I was mentioning before. So basically we start from the test list. We start from the templates, the input and the expected output. And before jumping into the test execution, we go through a preparation phase. In the preparation phase, we render the templates and we basically create the test files that are used to execute the tests. So we prepare basically the input files, the expected output files, and other files, which are used in the execution phase. And of course, at the end, we have the test results. What are the added values that we think this approach coupled with the process bring? So first, flexibility. We basically allow for validating or not, for rolling back the test case or not, and we allow also for specifying prerequisites. Another added value is the code reusability. So basically, we are using the same code base for multiple NSO service provisioning packages, and for testing multiple times the same package, right? And also simplicity of use, because since we leverage the same code base for all the test cases, there is no need to create new robot code, new robot script to add new tests, as long as, of course, the package can be tested with this approach. And we know that a robot framework has a human readable syntax, but anyway, there is no robot coding skill required to add new tests. Scaling, again, many packages and many tests per test suite. And finally, maintenance. Maintenance is a little bit of a gray area, because from one side we have advantages, meaning that leveraging the same robot code base, whenever we introduce a new feature that is basically available to the packages, to all the packages and all the test cases that we execute. But from the other side, of course, this comes with a cost, which is the robot code base complexity. And this might go a little bit against the good practices on the writing test cases on robot framework. So the conclusions, So in this session, we have seen the experience of Cisco CX about testing automation on NSO service provisioning packages. We think that this approach, together with the process, provides a trade-off between flexibility, code reusability, simplicity, and scaling, as we have seen in the last slide, or at the cost of robot code complexity. But we think it is worth, because in our opinion, at least, advantages are actually greater than drawbacks. And as a result, this is adopted internally in testing NSO service provisioning packages in our delivery team. And it is also used in our internal CI/CD pipeline. That's all I have for this session. Any questions?
So can you use this test to test any provisioning package?
Basically, yes. There are, of course, some limitations, I would say. It really depends on, for example, if on the specific device technology that is used, that your package actually configures. Meaning that this approach has been developed taking into consideration specific device technologies and specific nets, for example, the Cisco iOS and XR, just to name a couple. And if there are some which are new, let's say, if are different from the ones that are comprises, let's say, the code base will need to be expanded. Yes.
Okay. Thank you. So great presentation. Thank you.
Thank you very much.